Hi, so this is question number 21, still on concentration and number of moles related to stoichiometric calculation. That's a mouthful. If 1.5 grams of CaCl2 and 15 ml of 0.1 molar AgNO3 are reacted, what is the limiting reagent? So this one is not asking us to calculate anything, it's just asking us what is the limiting reagent, which one would get used up first. Okay, so I think this is question 21. Starting from question number 1, we've been emphasizing that you have to use your limiting reagent when you're doing calculations. It's very important. So this is going to be a review on how to get a limiting reagent again, working with questions like this. What you are going to put in the comment section for me will be the name of AgNO3. What is the name of AgNO3? What is the name of AgNO3? Is it calcium hydroxide? Let me know in the comments. Alright, so I hope I don't say the name while explaining all this. Alright, so let's look at the equation. Is it balanced? Is the equation balanced? It doesn't look balanced to me. Cl is 2 here, Cl is 2, that's good. Ca is 1, Ca is 1, fine. Ag is 1, and Ag here is 2, so it's not balanced. Our N is, the whole NO3, let me just take it together. The NO3 group is 1, and the NO3 group on the right hand side is 2. So I think if I should place a 2 here, I should help cater to the NO3 part as well as the Ag part at the same time. Isn't that wonderful? Yes, it is. So now it's all balanced. Very important. We need it balanced, okay, so we don't run into really big problems. Right, so now let's start with getting the number of moles of AgNO3 and also CaCl2. So first I'm going to do the molar mass of CaCl2 first. So that's going to be 40 plus 2 of the Cl, and each Cl is 35.5. So if you solve all that, you should get about 71 grams per mole. So that just means that the number of moles of CaCl2 would be the mass divided by the molar mass. Okay, and the mass is 1.5 grams from there. The molar mass is 71, so you can calculate that and you get 0.0135 moles. Alright, so this is the moles of CaCl2. Shall we get the moles of AgNO3? The concentration of AgNO3 is 0.1 molar, which is mole per liter. The volume, do we have volume? Oh yeah, we do. 15 ml, and 15 ml should be 15 divided by 1,000 in liters, right? That's the conversion. Okay, so let's just leave that like that. Now your number of moles would be concentration times volume. If you watched the question 20, the video on question 20, then that means you probably have a better understanding. And if you've not watched it, it should be in the description of this video. If it's not there, just drag us in the comment section so that we'll put it there, but it should be there ideally. Alright, so C times V, 0.1 multiplied by, what is the volume? 15 divided by this, and that will give you 0.0015 moles. Okay, so that's the mole of what? AgNO3, which I said you should tell me what the name of it is, right? So you let me know what the name of that one is. Okay, now I have the moles of CaCl2 right here and the mole of AgNO3. So I'll look at these moles I have, and then I'll look at the balanced equation of reaction, and I'll get what I call a ratio. Okay, you can do this like in your scratch paper also. Get what we call a ratio. That ratio would be the number of moles that you have solved out here divided by the stoichiometric coefficients, which are write as SC, stoichiometric coefficient. And what does that mean? It means this number here, 1 and 2, the coefficient that you have, numbers in front of your balanced equation, not just unbalanced. So for CaCl2, that ratio will be 0.0135 divided by 1, and for AgNO3, that ratio is going to be 0.0015 divided by 2. Okay, so if you should do that, 0.0015 divided by 2, that should be 0.00075, and for this one you still have 0.0135. okay, so here you can just put your units here, mole, right? 2 moles from the stoichiometric equation. So you realize that this ratio that we're talking about now would not have any units, okay, because it's relative to the stoichiometric coefficient. I hope all this grammar is making sense. Okay, so we won't put any unit there. But why are we doing this ratio? We want to see, the rate of reaction in a way, like how it does react. Okay, and now we can see that this is this number and this is this number. So the one with the smallest value here would become your limiting reagent. That's AgNO3. So AgNO3 is our limiting reagent since it has the smallest ratio. Okay, so that's one way to do this. There are also like different other ways that this can be done, and if you also have like a way you do this, it might even be simpler. So please share with us in the comments. But one thing I'll be looking for in the comments will be the name of AgNO3. Okay, so let me know what you call AgNO3, whether it's IUPAC name or common name, whatever, let me know. Okay, because there are some people that know it, and there's some people that might make some mistakes there. So let everybody learn from you guys, and I'll see you on question 22. Please subscribe if you have not subscribed, and follow this page if you've not followed yet. Okay, so bye bye.